I'm Jennifer Pulley. Welcome to another edition of NASA 360. All right, some of the talk around NASA's water cooler these days is about going back to the moon. And guess what? Much of the testing and hard work is going on right now. I mean, we already have prototype rovers, habitats, and vehicles built that are giving us a better understanding of what's going to be needed to make staying on the moon a reality. Now, of course, most of the testing can be done in NASA's labs, but there comes a time when you're going to have to take that hardware and put it to the test in the field. Of course, NASA's on it. Johnny Alonso followed some NASA researchers to a remote testing area to see how these new lunar rovers are being put to their paces.
Hey, how's it going? Let me ask you something. Have you ever taken a minute to think about how flawlessly everything must work when we go back to the moon? I mean, think about it. Everything from rockets and spacesuits to rovers and habitats, all must work perfectly. Oh, and let me tell you something. The moon isn't exactly the best vacation spot either. I mean, it's got like 0 oxygen, minus 250 degrees on the cold end, and upwards of 200 at its hottest. Oh, and let me tell you something. When you're on the moon, you're like 240,000 miles away from Earth. Yeah, so when we go, we better make sure that everything works exactly the way it's supposed to when we get there. Think about it. I can't even pack for a short vacation here on Earth. So here's the question. How do you pack for a trip like this and make sure that everything's going to work exactly the way it's supposed to on the moon? This is the exact situation that NASA's faced with right now. In the near future, NASA astronauts are going to be returning to the moon, so all their equipment needs to be tested here to make sure that it's going to work up there. To help test some of this equipment, NASA set up this really cool facility in a place that kind of resembles the moon. Where? Well, not too far from Seattle, Washington, in a place called Moses Lake. That totally fits the bill. So I flew out here to see what NASA's testing and to check out some of this equipment and how it's going to work on the moon. I'm here with Lucian Junkin. Thank you so much for giving me time today. Thank you, bro. And I'm here with Chariot. Why don't you tell us about Chariot?
So Chariot is the lunar truck that the lunar architecture team that is comprised of engineers and scientists from all over the NASA centers. They came together and they basically advised headquarters as what they think we ought to do on the moon. So they commissioned our team to build a lunar truck.
The Chariot has a really unique design featuring 12 wheels driven by 2 electric motors through a 2-speed transmission. This truck is really versatile. It can be used as a bulldozer, pushing with up to 4,000 pounds of force. And it's also pretty fast. Well, fast for the moon. It's able to reach speeds of about 15 miles an hour. It's designed in a way that allows the steel alloy frame to be fitted with several different crew payload combinations, including a small pressurized cabin and a sample collector, so it can serve in more than one function.
We took lessons learned from the rover, from the trucks here on Earth, from Sojourner, Spirit, Opportunity, all different sources to come up with this. Can I show you this real quick?
Sure, absolutely. Thanks. Thanks, man.
So this is the turret that allows the crew members to turn left and right. And then these are all of the controls that they have at their disposal. And similar to some of the software that we use, we have a button that we can actually toggle through the different pages that the operator can use. You can see this is a compass with an overlay of the land. And then probably one of the cooler features in the drive mode is the ability to go from vehicle mode, which means the front of your vehicle is this way, to a turret mode, which means that if you press forward on the joystick, then the vehicle will go forward to the operator.
Oh, wow.
So you can actually go forward and then turret, and the vehicle will strafe that way. So there are a lot of neat things that you can do with craft, just similar to a truck.
A truck, similar.
One of the key components when designing the Chariot was to have a vehicle with more wheels than a traditional lunar rover. NASA learned valuable lessons when the Mars Spirit rover had trouble with one of its 6 wheels. Even though the wheel could not be fixed, the other 5 were able to work, so the rover is still working fine, but is moving just a little slower. So with that in mind, NASA planners decided to build the Chariot with more than just 4 wheels. It would be pretty tough to have to change a tire on a 4-wheeled rover on the moon, so more wheels the better. The Chariot also can be the ultimate lowrider. It can lower its belly to the ground, making it easier for astronauts in spacesuits to climb on and off. Individual wheels or sections can be raised and lowered to keep the vehicle level when driving on uneven ground.
Let me show you one of the suspension modules.
Sure.
So this is the suspension module. a wheel module. This is an active suspension and passive suspension. Aaron, could you raise the... So you can see this coming off the ground.
Yes.
So each of these wheel modules are independent. So that means all of them can pull up and lower the belly to the ground.
Another cool thing about the Chariot is how its steering works. Called crab steering, the vehicle is designed to drive into the craters of the moon. If a slope is too steep to drive down safely, the vehicle could drive sideways instead. No backing up or three-point turns required. The all-wheels, all-ways steering also could come in handy when unloading and docking payloads or plugging into a habitat for recharging.
The lunar architecture team right now has it where we put assets, lunar trucks, athletes on the surface in mid to late of the next decade, 2016, 2017, to do civil engineering, construction work, basically berming and leveling. And then the crew arrives in early of the next decade, 2021 or sometime in there.
Quick question, why standing instead of maybe sitting?
We could have designed a sitting turret, but standing you get a better field of view. The suits are more friendly to standing up.
I feel it. Okay.
And so operationally it's easier to stand. It's like asking why do you stand when you cook. It's just something. It's just how it is when you're doing those types of activities.
Quick question. These rubber wheels.
They're not going to the moon, Johnny.
I didn't think so, man. Talk to us.
So the reason we use rubber tires on the 1G prototype lunar truck is so we can try out different treads on the thing because they're readily available. We're also in the back rooms of NASA developing wheels that are made out of Kevlar and titanium that will be more space-worthy and space-like, going to the lunar surface. So these pneumatic rubber wheels won't do on the moon. The ones will really be titanium or Kevlar or some other composite material like that that can take the hot and the cold of the ground.
Lucian, thank you so much for your time, man.
Thank you very much, Johnny. Thanks for coming to see us.
Definitely. Hope to see you again.
Take care.
Thank you. Don't go anywhere. We'll be right back. This is NASA 360.
Okay, here on Earth, if we have to move heavy payloads or structures around, all we really need to do is surf the web, right? Type in moving company, heavy equipment company. Well, what about on the moon? On the moon, it's going to be very different. So what are the astronauts going to do when they're up on the moon and they have to move things around? It's what NASA's working on right now. One viable solution they've come up with is to build a really versatile vehicle that can accomplish a lot of different tasks. This new vehicle is appropriately named Athlete. Here's Johnny with the Athlete test lead, Julie Townsend, to tell us all about it.
So I'm here with Julie Townsend. Julie, tell me about Athlete.
Athlete is the all-terrain, hex-limbed extraterrestrial explorer.
Okay.
It's a prototype for a lunar robot that would go to the moon to carry an astronaut habitat as a mobile home for the astronauts on the moon.
Oh, cool.
So this one is getting ready to do a demonstration. We're going to demonstrate. We have two of these vehicles here in the field right now. We're going to be demonstrating how well we can control them, how well they can keep the habitat level as we drive over different kinds of terrain, and the accuracy with which they can dock the two doorways of the habitats together to form a larger habitat.
Wow, and I mean, how many people can fit in one of these?
Well, right now it's probably about the size of your six-person camping tent.
Okay.
But this is a quarter-scale model of the one we'd send to the moon. So the one we send to the moon would be 4 times bigger in every dimension.
Okay, so this is a prototype? Or?
This is a prototype, that's right. This is a concept development. So what we're trying to do here is prove that a robot like this can do the job and do it well.
Okay.
So that we can prove that it's worthwhile to fund developing it into a flight mission.
Okay, so that's a habitat where people can live, right? What else can athletes do?
Well, Athlete is kind of an all-purpose utility vehicle.
Okay.
So it's got the flat platform on top, which the habitat is currently mounted on.
Sure.
We can mount other kinds of payloads on that habitat. In fact, we did one test this week where we actually mounted the Langley crane on top of it.
Really?
Right, and then that's a bit too heavy for us to lift in Earth gravity, but the idea would be that Athlete could carry that kind of a crane around on the moon. Also, because each of the legs has a full 6 degree of freedom manipulator with a wheel on the end, when you set the Athlete down on the ground, it can sit on pads on the ground and become a platform with 6 fully articulated robotic arms. And on the ends of those limbs, we can actually attach tools, like grippers and drills and things to do a bunch of any sort of different activities on the moon that we want. It's a very versatile vehicle.
Very slick.
One of the things that it can do, because it is so easily manipulated, we can move it around so many different ways. It's great for payload handling. So, for instance, say we didn't want to carry this habitat around, we could put it down, we could pick something else up. And we've done demonstrations where we've shown how an Athlete can drive underneath a lander and pick it up and drive it around.
Yeah.
You've even done one demonstration where we used the 2 Athletes cooperatively, and they picked up a payload between them.
Really?
And manipulated it onto the ground. Not the most efficient way to operate, but you know, it was really, really cool.
Yeah. Solid. Julie, can you tell me how are they operated?
Well, they can be operated in a lot of different ways. We're from the Jet Propulsion Laboratory, the home of the Mars exploration rovers, and we're very experienced at operating robots on other planets. So what we envision is that when the astronauts were on the moon, they would operate Athlete locally and be able to drive the habitat around. And then when the astronauts came back to Earth, we'd be able to operate them remotely from Earth to move them to another site.
Oh.
Like, so they could go to meet the next astronauts that were coming to land on the moon, or they could go to an outpost site to be collected into a larger habitat.
Sure. So it can be powered from Earth as well as...
That's right. It could be controlled from the surface of Earth. It's actually easier to control a vehicle on the moon than it is to control one on Mars, because the light time, the distance to the moon is so much less that it actually takes a few seconds for a communication message to get from the surface of the Earth to the surface of the moon. Whereas Mars could take, you know, it takes minutes to a half of an hour just to get a message from here to there. So the benefit of having a vehicle like this for the lunar mission, that'll make it, like, help us increase our capabilities beyond what Apollo could do, is that being able to have a habitat that can move with the astronauts will allow them to explore a lot more of the moon. They won't be as restricted to stay within an area close to their landing site. They'll actually be able to take their habitat with them and go on much longer excursions.
So this is going to go with them, right? But if they're like on a day trip, I mean, could they attach a rover with them or anything? Or?
Well, actually, if Athlete and the habitat are like the robots or like the astronauts' mobile home, then the Chariot robot is like the astronaut's car or truck, right? So they would get into the Chariot and possibly a small pressurized module that could ride on top of Chariot to go for short excursions. And actually there are plans for that pressurized module on Chariot to actually be able to dock directly to the habitat. So these robots are a little bit more capability than you would really need here on Earth. But you need that kind of capability on the moon because, you know, if you're on the moon and you get stuck in a dune field somewhere, you can't call the towing company to come and get you out, right? Your robot has to be capable of getting itself out. You don't want those astronauts out there on EVA in their spacesuits, you know, putting boards under the wheels trying to get the thing out of there, right? This robot can actually, you know, if its wheels do happen to dig into the sand, it can pick up and start walking. You know, it can get up high slopes, it can go where the sand is really loose, places that a truck might get stuck.
Sure, full service.
Full service, that's right.
I love it.
Okay, so one of the first missions that's going to need to be accomplished is to find ice on the moon. Now, if we do that, we should be able to use it for drinking, to make oxygen, and even make fuel. Researchers believe there is ice in the dark craters of the moon, but we're going to need a really robust rover to get to it. SCARAB is the prototype vehicle that's designed to do just that. Here's Johnny to tell us more.
And one of the things NASA's testing is for a rover that can look for water or ice, and my buddy Paul is going to talk about it. So, Paul, give us the lowdown on what's happening here.
Okay, so as far as the why to go look for ice on the moon, it's You know, at first it sounds kind of surprising that there would be any, but you know, there are actually these dark craters on the South Pole that never get light. The sun comes in this kind of grazing angle, never gets down to the bottom. So it's like the dark side of the moon, Pink Floyd myth. It's actually true in these things. But we've got just indirect evidence so far. We want to send something like SCARAB into these craters to get direct evidence.
Really?
The useful thing about it is that you could actually break it down and use it as a resource, like not just as a consumable for astronauts, but as a fuel. So you could go there, fuel up a spacecraft, and come back, or maybe go on to Mars.
Really? Well, tell us a little bit more about this.
Yeah, so we try to think about drilling as the main kind of driver for the vehicle. Like, have to design around this pretty big drill, something that's bigger than an inch diameter. Something that would be pretty hard to do by hand. Go down a few feet deep into the ground. And so we thought of this really slow, strong kind of machine to do this heavy task. So we designed it kind of like a donut around this drill. You can see that stand-in drill there.
Yes.
That's kind of to simulate the mass of it, so that it feels like it's there for the rover while it drives. But then, so Scott's driving it now. You can see that this is its kind of normal pace. It's driving out now.
This fast, huh?
This is about as fast as it gets, yeah. But it turns out it's fast enough to get the mission done. I guess one of the nice visible things about it is the suspension. I mean, you're seeing this kind of all the hardware that connects between the wheels. We kind of call these the shoulders, where it rocks around those shoulder points, and then this beam connects the two sides together. So that's all passive joints. It's worked out really nicely for us. And one aspect we haven't talked about so far is the way it navigates in this total darkness. You can't just sit there and take pictures. There's no light basically coming. And it turns out if you want to take really far shots, see far in the distance, the flash illumination, it doesn't work out very well.
Sure.
So we've been experimenting with some laser systems. So you are pointing lasers, shining out into the surroundings and seeing what bounces back. So these are two different scanners we've been experimenting with. This one's kind of been using as it's almost like a virtual bumper. It paints a laser line, a stripe out in front of it, a few feet in front of the nose, and make sure there aren't any big obstacles in the way.
Neat.
And if they are, the software sees that and responds, finds a better path. And then this is a much more complex device. It's really nice, called the TRIDAR. This one's actually it can get bigger scans, like really detailed, nice 3D meshes, these 3D maps of the terrain around the rover, and then it can choose the best paths through.
So, bro, is this a test model or a prototype?
Yeah, exactly. It's kind of testing out an idea for how to do this kind of drilling and driving in these cold craters, dark craters on the moon.
Like here?
Like here, a little bit, yeah. I don't know why it's so cold.
It is.
So yeah, basically, as far as the background, that NASA's Human Robotic Systems program is the one we're developing this for. They came to us with the needs, what the rover would need to do, and then and so we're at Carnegie Mellon's Field Robotics Center, and so we came up with the concept, kind of in coordination with them, and then built it last summer.
Well, thanks for your time and for everything with Carnegie Mellon and having us aboard, man.
Thank you very much.
Thank you, bro. Check it out. You see some guys in spacesuits, but not all of these spacesuits are NASA spacesuits. Some of these suits are props. Right, props from a Hollywood prop house. Let me try to explain.
All NASA spacesuits are pressurized, which makes them basically their own self-contained spacecraft. This pressurization is great when you're in a 1/6 gravity environment like the moon, but you don't need to have all the suits pressurized for this testing. So NASA had some unpressurized suits made in Hollywood. These suits are much lighter than the real suits, but can still help test ergonomics and ease of movement. A couple of other benefits of the Hollywood suit is that they'll be more comparable to the actual weight and feel of suits once an astronaut gets in 1/6 gravity. So astronauts will feel similar to the way it feels on the moon. And the suits won't have to be recharged like a pressurized suit does, so work won't have to stop as often.
Pretty cool, huh? Those suits are amazing. But obviously, real prototype spacesuits were tested as well. I'm going to throw it back out to Johnny again. He's with spacesuit technician Bill Welch to find out more about this new suit and how it's going to work on the moon.
So, I just saw you in the field wearing the suit. Can we talk about the suit?
Sure. The suits that we're running today were future Lunar and Mars surface suits, test beds actually. we're trying to take and incorporate some changes into the suits that they didn't have during the Apollo days, which will enable them to be able to walk on the moon's surface rather than hop as they did before. The hopping, that while worked better than walking, was fatiguing for the astronauts. It was very hard on the calves and the ankles. So in order to take and alleviate that, we've incorporated bearings into the hips and into the ankles of these suits to allow a more freedom of movement. As you can see, we have a bearing here, here, and here, which allows for good freedom of movement. Another thing that they don't have, that they didn't have on the A7L, which was the moon suit, was the waist bearing. I don't know if you noticed while I was walking, but there was a lot of swivel in the hip. That's really big. That makes a big difference as far as comfort, being able to move freely in the suit.
Is it really difficult to get into a suit like this?
Well, no. The cooling garment, if I can take and grab one here. Excuse me, folks. This is the cooling garment. This is what we wear on the inside. This is being flown right now. This is used in the EMU upon shuttle and station. What we do is you can see all the tubing running through it. We pump cold water through that tubing to keep me cool inside the suit so I don't overheat.
No kidding.
Yeah. And as you can tell, it's fairly slick. It's a tight-fitting suit.
Right.
So we'll roll this ladder up behind. I'll take and sit on the seat. I'll hook up my water lines, which come off from right there, and then hook onto right here.
Right.
Okay. And once that is done, basically what they'll do is they'll just, my suit techs will take and grab hold of the toes of the suit and pull them forward, and I just drop right in.
Really?
And then once I'm in the suit, they'll take and finish up my connections. They'll put in my earbuds so I have my radio communications. My microphones are already in place. They'll hook up my shoulder pads. At that point, they'll close the back door, put on my gloves, get the airflow started, put on my helmet, pressurize me up, and out the door I go. So basically the concept of these suits is to be able to take and either leave them outside the vehicle and be able to put the back in. And we are just out here trying to provide the best product possible for the future of lunar surface and Mars surface exploration.
So this is basically like your own little space shuttle.
Indeed it is. It's our own little spaceship, just like the EMU out in space. Once they leave out of the airlock on the space station, they are in a spaceship. They have their telemetry, they have their batteries, they have their cooling, they have their air, they have everything. They even have the capability, should they come disconnected from the space station, to be able to drive themselves back. They have a little gaseous nitrogen rocket motor that is hooked onto them, and they're able to take and drive themselves back in an emergency situation. So yes, they definitely have their own little spaceship, and that's what we're working on, is having your own little Moon Mars rover.
Well, it's been a pleasure talking to you.
Indeed.
Thank you, sir, right?
Take care.
Most definitely.
Well, today we saw some pretty cool concept vehicles that may one day be used on the moon and on Mars. And all that harsh testing we saw, it can only make the vehicles stronger and more reliable once they actually do get on the moon. And who knows, maybe one of you watching will be driving one of these vehicles in the very near future. That's it for now. For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360.
So we mentioned the athlete was vertical.
We do it again? Yes, really?
If we have to move heavy payloads or structures around, all we really need to do is surf the wet.
Some of these suits are props. Props from a Hollywood house out in... Do it again.
Catch you next time on NASA 360.
This is exactly the situation that... So.
He's with a spacesuit technician to find out how these suits are going to work and on how they're going to work on the moon.
Hey, how's it going? Let me ask you something. Have you ever taken a minute to think about how flawlessly everything must work when you go to? How do you pack for a trip like this? Nope. I can't even pack for a trip for...